Human-rated space systems, everything from launch vehicles to spacesuits to surface habitats to lunar rovers, require extensive failure recovery planning to deal with the risks of operating in the unforgiving environment of space. For a given failure scenario, recovery planning must account for key systems like life support, navigation, propulsion, and communication. When part of a system fails, the failure effects can ripple throughout the system and can impact recovery plans for subsequent failures. Of course, failures aren't the only things that can have ripple effects. Changes like addition or removal of components, or arrival or departure of crew, can also affect failure recovery planning. The next generation of space missions will be long-lasting. The original failure response plans will require repeated review and updates to ensure that they are up to date with the system configuration. As mission duration and complexity increases, managing the propagation of design changes to failure recovery plans will require an unsustainable expenditure of human time, effort, retraining, and support. How can we address the need for failure recovery planning while avoiding undue cost and efficiency burdens? Enter FRIGATE, an innovative leap in failure response planning. FRIGATE drastically reduces the amount of effort to manage change in human-rated space systems. Here's how. FRIGATE monitors and maintains the relationships between three elements of a mission: mission goals, mission rules, and system design. It generates and validates failure recovery plans that adhere to the goals of the mission, the safety rules of the mission, and the capabilities of the system. And it automates the maintenance of failure recovery plans to keep them consistent and correct with evolving system configuration and composition. For example, in the case of NASA's ARTEMIS program, the mission goal to establish a long-term presence on the Moon depends on the design of the systems that will house humans on the lunar surface, as well as the mission rules, such as the safety margins for available consumables. Using automated reasoning, FRIGATE helps engineers determine how any failure or configuration change affects failure recovery plans and suggests corrective measures. As a system evolves through design, deployment, and sustainment, FRIGATE automatically checks and rechecks the validity of the failure recovery scenarios in the overall mission plan, helping to keep human crews safe and focused on mission success. As we return to the Moon and venture toward Mars, where communication delays make reliance on ground-based support untenable, this kind of failure response planning will be more important than ever. As projects journey further into space, FRIGATE will automatically perform critical change control management independent of the communication gaps and lags associated with a traditional ground-based support response. To learn more about FRIGATE, go to galwa.com.